Welcome back students to another lecture of chapter 8, that is motion. In last lectures we studied about distance and displacement and we solved numericals also related to this. But during distance and displacement time is also taken, right? So now we are going to deal with the quantity which is relating this distance and time. And this quantity is called speed. Speed is defined as the time rate of change of distance of the body, or speed is defined as distance traveled by the body in unit time. That is, how much distance traveled by the body in unit time. Unit time means it can be 1 second, 1 hour, etc. depending upon the unit we have taken. So what is speed? Distance traveled by the body upon time taken. If body is traveling distance s, distance traveled by the body is denoted by s, time is denoted by t, then speed v, speed is denoted by v. So v is equal to s by t. This is the formula for speed. Now speed is equal to distance upon time, that is v is equal to s upon t. Distance is a scalar quantity, time is also a scalar quantity, so obviously speed is also a scalar quantity. Speed is either positive or zero, it can't be negative since distance can't be negative. Speed of vehicle is measured by speedometer. Students, all of you know a speedometer is there in the vehicle which measures the speed, and another device is there which measures the distance traveled, and that is called odometer. Don't get confused between speedometer and odometer. Speedometer measures the speed and odometer measures the distance traveled by it. Speed is measured in centimeter per second, which is its CGS unit, meter per second, which is SI unit, or you can say MKS unit, and it is also measured in kilometer per hour. Suppose that the distance traveled by a car in 4 hours is 20 km. So what will be its speed according to the formula? Speed is equal to distance traveled upon time taken, that is equal to 20 by 4, that is equal to 5 km per hour. Now what does this 5 km per hour mean? Is it mean that from starting till up to the end of 4 hours the car is traveling with 5 km per hour? Is it possible that from the starting only it will be having a speed of 5 km per hour? No, gradually its speed will increase. Similarly, in between, suppose any obstacle is coming, then its speed will decrease also. So it is not possible that for the whole journey the car is traveling with a speed of 5 km per hour. Then what is this 5 km per hour? It is the average speed of the car with which it was traveling during this period of 4 hours. So let us see what is average speed. So average speed of a body is the ratio of total distance traveled to total time taken to cover that distance. That is, average speed is equal to total distance upon total time. Average speed is denoted by V, AV. V is for speed and AV is for average. That is, VAV is equal to S total. Distance is denoted by S. So S total upon time total. That is total distance traveled upon total time taken. Let us see the example given over here. That a car covers first 25 km in 1 hour, next 35 km in half hour, and last 30 km in 1 hour. So here car is traveling different distances in different intervals of time. So for finding average speed, we'll take total distance upon total time. Total distance traveled is 25 plus 35 plus 30, and total time is 1 plus 1 by 2 plus 1. So total distance upon total time is 36 km per hour, which is the average speed of the car. Let us see another example. A car travels 32 km during the first 2 hours, then it travels 13 km during next 2 hours, and we are asked to find the average speed. So average speed is equal to total distance upon total time. Total distance is 32 km plus 13 km, that is 45 km, and total time is 2 hours plus 1 hour, that is 3 hours. So average speed is equal to 45 by 3, that is 15 km per hour. Now what is uniform speed? A body has uniform speed if it travels equal distance in equal interval of time, no matter how small these intervals may be. We know that if a body is traveling equal distance in equal interval of time, it is uniform motion, and when it is in uniform motion, its speed is also uniform. Next is variable speed. If a body is said to be moving with variable speed if it covers unequal distance in equal interval of time, howsoever small the intervals may be. So when it is performing non-uniform motion, it will be having variable speed. Next is instantaneous speed. When a body is moving with variable speed, the speed of the body at any instant of time is called instantaneous speed. Suppose that you are going in your vehicle and you see to the speedometer of your vehicle. Then the speed that you are seeing at that particular instant of time, that is called instantaneous speed. So students, here you can see that speedometer of a car is shown and the speed of the car at that particular instant is 50. So the instantaneous speed is 50 km/h. A speed shows how fast a car is going at one point in a time or at one instant. The speed shown on the speedometer is the instantaneous speed, and it is the speed at any given point of time. Students, now you very well know that distance and displacement are almost same. The difference is that the displacement is the distance with direction, right? Same way speed and velocity are related. If it is speed with direction, then it becomes velocity. So now let us see what is velocity. Velocity is defined as time rate of change of displacement of a body, or the distance traveled by the body in unit time in given direction. So velocity is equal to distance traveled in given direction upon time. Now what is distance with direction? It is displacement. So velocity is equal to displacement upon time. We know that displacement is denoted by s and time is denoted by t. So velocity is equal to s by t, that is displacement upon time. So students, we know now that velocity is dependent on displacement, and displacement is which quantity? Vector quantity, right? So velocity is also a vector quantity. Direction of velocity is same as the direction of displacement of the body. Velocity can either be positive, zero, or negative. Velocity can be changed in two ways. First one, by changing the speed of the body, or by keeping the speed constant but by changing the direction. Suppose that velocity of a car is 25 km/h from A to B, that is, car is going from A to B. Now after some time, its speed is changing from 25 to 26 km/h and it is moving from A to B only. So here velocity is changing due to change in speed. And suppose that it is moving with 25 km/h only, but from A to B, now it is going from A to C. Then here direction is changed. Then also its velocity is changing. Then of course you will ask, ma'am, if speed and direction both are changing, then yes. If speed and direction both are changing, then also velocity of the moving body will change. So in above example, if speed is changing from 25 km/h to 26 km, and instead of going from A to B, it is going from A to C, then here speed and direction both are changing. Then in this case also velocity of the body is changing, means velocity of car is changing. Now velocity is measured in centimeter per second, which is a CGS unit, meter per second, that is SI or MKS unit, and it is also measured in km/h. Uniform velocity. A body is said to be moving with uniform velocity if it travels in a specified direction in a straight line and moves over equal distances in equal interval of time, no matter how small this time intervals may be. Then it is said to be moving with uniform velocity. Means if it is traveling in a fixed particular direction with constant speed, then it is moving with uniform velocity. And if its velocity is changing with time, we know that how velocity may change. Then it is said to be moving with variable velocity. Next is average velocity. When a body moves with variable velocity, the average velocity of the body is ratio of total displacement covered by it and total time taken. The formula for average velocity is initial velocity plus final velocity divided by 2. That is u plus v by 2, where u is initial velocity, v is final velocity, and t is time taken. Students, you have to keep in mind that initial velocity is denoted by u, final velocity is denoted by v. So if initial velocity of the body is u and after a particular interval of time t its final velocity is v, then its average velocity during that particular interval of time can be calculated by using the formula u plus v by 2. Now, instantaneous velocity. When a body is moving with variable velocity, then velocity of the body at any instant of time is called its instantaneous velocity. So, students, now let us recall what we studied in this lecture. We'll consider the main points. First of all, the difference between speed and velocity. Here you can clearly see the speed of car is 20 meter per second and the velocity of car is 20 meter per second in east. So when direction is added to speed, it becomes velocity. So velocity is speed in given direction. Now let us see the difference between speed and velocity. First of all, speed. Time rate of change of distance of a body is speed and time rate of change of displacement of a body is velocity. Speed is a scalar quantity, velocity is a vector quantity. Speed can be positive or zero, velocity can be positive, negative or zero. Average speed of a moving body can never be zero. Average velocity of a moving body can be zero. Then we also studied uniform speed, uniform velocity, variable speed, variable velocity, instantaneous speed, instantaneous velocity, along with average speed and average velocity. So that's all for this lecture. We'll continue the other topics in the next lecture.